the sixth in our sixth series of Lunch and Learn presentations, which are collaboration between the Bermuda College and BEST. I'm here representing the BEST team today, as Jennifer's traveling. So welcome, and welcome also to the people who are listening and tuning in through YouTube. It's my pleasure to introduce Nick Hutchings. Nick has actually been given a number of presentations here with the Lunch and Learn series over the last 6 years. One, I thought you gave one on solar and one on climate change in the very beginning.
Yeah. One. This is the solar one.
This is the solar one. So today's presentation is the role of solar in a sustainable future for Bermuda. And Nick is going to share good information with us on the value of investing in solar, the value to the environment of installing solar, the value to public health, and energy sustainability. So welcome, Nick. Thank you very much. Thank you.
Well, thank you all for coming. Everybody can hear me. It's great. We've got this mic here. I don't have to yell. So I'm afraid it's not very good news. But before I get into that part, I'm just going to start. I want to introduce you to the company that I work with, which is Sunnyside Solar, and talk a little bit about why solar is so great. What's so great about solar? Now, all I need to do is figure out, there we go. Let's try that. Okay, good. So Sunnyside Solar, I see we have some other people in the solar industry here. So we're exactly the same as them, although maybe we're not quite as good at marketing. We're a relatively new entry in the industry. We've probably done 70 or so residential installs and 5 or 6 nonprofit or donations. But we're a nonprofit company. So we set up a company. It's limited by guarantee. Therefore, all of the money that we make when we sell our solar has to be used for charitable purposes. So we started out with donating a system for the Transformation of Living Center. You probably noticed the system on Meals on Wheels. We donated that. We've done a Christchurch to support their feeding program there, saving them a lot of money. We've helped out the Bermuda Society of the Blind, Vision Bermuda. And, also, we've installed some solar on the Trunk Island for BZS. So, like I said, we're actually quite competitive. We base our business model. This is just a simple cost plus 20% business model. We keep our prices low by minimizing our overheads. We've got good, solid, reliable product, just like the other companies, solid engineering, no guarantee. Solar is really good. It's an excellent return on investment. And like I said, 100% of our earnings go to charity. So what is so great about solar? Solar is good for a bunch of reasons. One is it really is a good investment, payback from 5 to 8 years, depending on how much you self-consume. The more you self-consume, the more you save. It's great for the environment. An average system will save up to 150 tons of CO2 in the atmosphere over the life of the system. This is also interesting. It's really good for public health. The Union of Concerned Scientists have put the hidden cost of burning oil for generating electricity at 13 cents a kilowatt hour. So That's based on some research done by scientists at the U.S. Environmental Protection Agency. It's, you know, probably up for debate, but one thing we can say for sure, it's not nothing. The public health costs of burning oil to generate our electricity is not zero, it's something. And it's probably something in the range of 13 cents a kilowatt hour. And that's unpriced in the cost of the electricity that we but somebody's paying for it. We're all paying for it anyway. We're paying for it in lack of productivity and the economy, and we're paying for it in taxes. So it's not for free. We're paying for it. Solar knocks that down. It's also great for the economy. I mean, anybody here, there's some people in the industry, so I should know this. Anybody here know how much electricity we burn daily in Bermuda? Any idea? Would you be surprised to learn that that's 1.5 million? Yeah, 1.5 million kilowatt hours a day. That's what we burn. All right. So now, if you start doing a little math, multiply that by 13 and by 135, you get up to a pretty big number. Also, it's good for the economy because, you know, for every solar panel you put on, you knock down the cost of oil that we import. And that's money, all the money that we spend on oil, that's getting shipped out of the economy, and it doesn't do anything for GDP. GDP is the value of goods and services that are within the local economy. 2019, it's the last annual report that we have for Ascendant, and I haven't been able to get any information out of the new owner of Belco. But yeah, they spent $93 million on oil. Mind you, probably 30 million of that was duty, but that's another $663 million that just vanishes, just gone, bleeds out of our economy. Solar is also great for energy security, which is what I'm going to be focused on today. So I said, it's not good news. This is the World Meteorological Organization. Last year was the hottest year on record. Not only that, last year we hit 1.5. Last year we hit 1.5 degrees centigrade over pre-industrial revolution temperatures. That wasn't supposed to happen for another 20 years. And oh yeah, maybe it's El Nino, but it happened, and it happened earlier than anybody expected. So this was from a report in November. Yeah, so it's been confirmed. We know greenhouse gases levels continue to rise. We have record sea surface temperatures, which is really important for us because where do we live? In the ocean. And last month, in fact, was the highest recorded temperature of sea surface since we've been keeping records. We're losing Arctic sea ice, and we have we're seeing extreme weather that's causing death and devastation. So in 1980, Exxon hired some climate scientists to do a study. And they predicted this black and white graph. That's a page out of that study. And they predicted that business as usual, we would see CO2. This is what they predicted. This was 40 years ago. Temperature. That's what they predicted. So 1920, some other climate scientists thought, well, I guess they dug this study up from somewhere. They said, well, wouldn't it be interesting to see how these guys did? You know, how good were they at predicting the future? So they have actual real data from that date, and they overlaid it. So this is how much CO2 was actually been pumped into the atmosphere, and this is what the temperature actually has done. So they were pretty smart. 40 years ago, they knew what they were talking about. Actually, the oil companies knew as well, or at least they were told. Whether they wanted to believe the scientists or not, well, that's still a problem today, because there are lots of people that are not particularly interested in that message. So I was curious. I thought, well, what's it look like? And particularly for Category 5 hurricanes, which are the most destructive. I mean, you know, regular Cat 3 hurricanes we're not particularly concerned about in Bermuda. There's a little bit of damage, but we handle those pretty well. Lights might go out for a week, you know. But Cat 5 hurricanes, something we've never seen up here. And, you know, I was wondering, are they increasing? So I went on, did a Google search. They took me to the National Hurricane Center. I asked them, how many Cat 5 hurricanes have been recorded in the last 80 years? And that's what I got. I split it right here. This is 1980, when those climate scientists at Exxon did that study. So we see a trend. In the last 40 years, there were almost twice as many Category 5 hurricanes as there were in the previous 40 years. And what's really interesting is Cat 5 is open-ended category. But if you go, if it's 26 miles an hour between a Cat 4 and a Cat 5. So if you go, okay, we give it another 26, if we follow that logic, then anything over 26 becomes a Cat 6. So that's actually 182 miles an hour. So if we want to look at, we could say, well, how many Category 6 hurricanes have there been since those climate scientists at Exxon predicted heat and CO2? So if we look up this recorded 1935, that's a Cat 6. Because that's over 182 miles an hour. Now we come down here, the last 40 years, here's 1, 2. It's close, but not quite. 3, 4. 1 in the first 40 years, 4 in the last 40 years. So I'm just gonna pop back to the previous slide for a second and say something that I forgot to say. Is that all of this heat, see all that heat? 90% of that goes into the ocean. And I'll just remind us, you know, where do we live? And it's basic physics, high school physics, right? Heat equals energy. And it's that energy that's driving all of these big storms, and it's only going to increase. Sorry. Ha. First of its kind. Oop. One more. There we go. Now that should really scare everybody in this room, because it definitely scares me. 2015, they recorded a Category 7 storm. Sustained winds of 213 miles an hour. Well, we don't know about it because that peaked. That was actually peaked in the Pacific Ocean just off the coast of Mexico. By the time it went ashore, it was downgraded to a Cat 4 and it went ashore in a relatively unpopulated area. And it was like easy to forget. But once you've seen this picture, so, you know, I can guess maybe what some of you are thinking right now. I used to think it, you know, we live in Bermuda. We have much better building codes than, say, the Caribbean. And we handle our hurricanes better. And that's probably true up to a Cat 3, maybe even Cat 4. But we're not ready for this. This is PEI 2017. They had back-to-back Category 5 hurricanes. And, you know, the devastation that it caused down there is just kind of hard to imagine. But one thing, when it comes to energy security, one thing that a storm of that magnitude will do, it will completely destroy all of your distribution infrastructure. So everything from the substations to your homes is going to be gone. And okay, that's bad news. What are we going to do about it? Well, one of the things we can do about it is we can take advice from the people who live in the Caribbean and have gone through it. We should listen to what they tell us. So I know Annie was there. The following year, this is Dr. Pickering. He was the deputy premier of the British Virgin Islands when those hurricanes hit. He came up to Bermuda and he talked at the Ocean Risk Conference here. And he basically said, look, if I was you guys, I would diversify my energy supply. Now, he probably didn't rhyme it. I rhymed that because it's easier for us to listen to remember. Diversify your energy supply. That's the advice he gave us. Okay, there are several ways you can do it. In my opinion, the best way to do that is with distributed solar. So imagine if all the people had solar. This is after 2 Category 5 hurricanes. Okay, notice which of the roofs is still intact. So I would ask you, which roof would you rather be living under? This roof or that roof over there? This roof, you're dry. You're dry, you can put some batteries on that. You've got AC, you know, you don't have to throw away all your food, you've got refrigeration, you've got fresh water, hot water. The difference in the quality of life after one of these storms between people who live under this roof, people who live under that roof, is extraordinary. And unfortunately, what we're seeing happening in the industry in Bermuda is we're seeing yet another divide, another social divide happening in Bermuda. Very simple now. It's going to be those that have solar and those that don't. And those that don't are really not going to be very happy. So what my message is today is that we, all of us in the solar industry, hope that one day those of you that don't have solar will join us, because it's going to make a big difference in the quality of your life. And I think it's not a matter of if one of those monster storms come up here right now, the way things are going, it's really a matter of when. So how are we doing time-wise?
After.
I have a couple of slides, and I've been looking at a little more in depth on this, the heat in our atmosphere driving hurricanes and major hurricanes. And there are a couple of factors that play. It's not just as simple as the ocean's heating up, therefore the storms are going to get stronger. Well, that's true basically, but there's some other factors that play here. And you've probably heard of El Nino and La Nina. Okay, and then last year, people will say is that we hit 1.5 last year because of El Nino. So El Nino is the warm air in the Pacific is blowing this way. Fewer hurricanes, because what it does, it brings the jet stream lower, down like that, and the jet stream knocks the top out of hurricanes. So El Nino's, for Spanish, is little boy. Little boy's like a lion tamer. Okay, El Nino, he goes in the cage with the lion. He's got a chair and a whip, and he tames the lion. Okay, El Nina, the little girl, she's not interested in taming any lions. As a matter of fact, what she wants to do is open the gate and let the lion out. Because now, although the temperature is coming down a little bit because the hot air is all going that way, right? We have more hurricanes over here in our part of the world because now the jet stream's running up here and the tops don't get knocked out of them. And there's one more piece of this puzzle that we have to consider. And that's called the Atlantic Multi-Decadal Oscillation, or AMO. And when you have it in the warm part, you get more hurricanes. You have it in the cool oscillation, part of the oscillation, you have less hurricanes. So if you get this, plus the little girl opening the gate, then the potential for really destructive hurricanes increases. And sorry. This is where we are now, or last year. Just thought I'd let you know that little bit of bad news. So when I started this by saying that it's not good news, I was serious. It really is not good news. And we are looking at moving into a phase within the climate-driven weather, the threat of extreme weather because of the climate, the threat of global warming and climate change is very real. The data is now really supporting that. And I think the sensible thing to do as a community is to start to prepare. Okay, if everybody in this room put solar on their house, didn't burn any more fossil fuel, it's not going to change this. Right? I mean, we should probably do that just because it's the right thing to do, but it's not going to change this. We don't have the power to change that. The only thing we can do is start to prepare. That's my message for today. Thank you very much. you have any questions, I'd be happy to do my best to try and answer them.
Nick, where are we? The El Nino or the El?
Okay, last year we had El Nino. That is predicted to end, actually was predicted to end this month. Then we go into a neutral phase, but they're expecting El Nino to kick in July.
What causes those to,
Yeah.
Sorry?
what causes those to change? And
That's a little more, that's above my pay grade, but it has just something to do with the circulation of cold and warm water in the Pacific.
So Nick, is it when there's warmer, like in the El Nino phase, if there's warmer waters in the Pacific, does that then immediately mean there's cooler water in the Atlantic?
or is it just by,
Well, that would be nice, but don't forget the AMO.
So, okay, it's driving.
So, and the other thing, of course, is that the water will cool down a lot slower than the air. So what's happening is through these oscillations of El Nino and La Nina is the sea surface temperature is just on a steady trajectory. It's just a matter of how fast it's going up every year, but it's going up every year. It's not coming down.
Nick, when can we expect to see the size of these panels decreased and produce the same amount of power?
I don't know. There's
Possibility?
not anytime soon. I know there's a lot of research on that, but what's the reality is that the panels are getting bigger. And it's a struggle for us in the industry because now we're having to fit bigger panels between the ridge line and the gutters. Because everybody wants more power, obviously. I mean, I've only been doing this for 3 or 4 years now, and you know the first panels we were installing were 320, and now they're 395.
440s, 550s?
And well, yeah, if you want to go even bigger, you can go all the way up over 5.
What's that number? 354.
Wattage.
That's watts. Yeah, yeah.
But
So
essentially,
surely, and I'm not very smart,
Yes, you are.
there must be a chips decrease in computers and all the rest of it. So should we not expect to see something similar in these solar panels?
The main problem is the crystallization structure. The arrays in each panel, the crystals that they need to create in order to convert sunlight into energy, they have problems with reducing the size of those anymore, which is what dictates the size of each of the modules on a solar panel.
but as Nick said, there's a lot of research going on. There was an announcement from China where they basically been able to increase the efficiency in the conversion rate. Okay. There is a new material that's actually being deployed on satellites, which is called perovskite. And essentially, it's a regenerating material. So you don't get so much of the degradation, but it uses sunlight in order to regenerate itself. Kind of a bit like a self-fulfilling prophecy. But the technology and the cost is obviously out of reach for the general market. So, but obviously the more that it gets deployed and the greater the demand, then it will come down to this level. But there's no compelling research coming out about actually being able to reduce the
footprint at
size
all.
of those particular cells. Yeah.
It'd be having the same size panels be more efficient. It wouldn't necessarily be being able to shrink them down.
So not in
Not in my lifetime.
not in our lifetime. Yeah, we're stuck with that. They're making incremental small changes, making them more and more efficient, but they're relatively small changes.
The other question I have is, in other countries, we see windmills that produce power, wind power. We don't see that in Bermuda. I'm not sure if that's a planning issue or if it is an issue.
Yeah, there's actually been a very good reason for that. Solar panels have no moving parts. Windmills have lots of moving parts. So the maintenance issues on them for small turbines is difficult. But I have seen just recently, particularly after last spring, when we had all that cloud cover and all that rain, and I was watching the production on my solar just dip. And I was thinking, well, maybe a small wind turbine in combination with solar might be a good thing. And I see people now are starting to produce small residential wind turbines that are price competitive with solar. So in terms of, it's about the same price to get the same amount of electricity, and I think probably give it a few more years just to make sure that they get all the bugs out. But I'm seriously thinking about it. I've got my eye on one.
Well, I take your point about the maintenance, because we live in a very salty environment and rust just takes over everywhere.
Yeah.
Unfortunately, a very Bermudian problem that we run into.
It is, but if you live on the south side of South Road, you just take that problem and multiply it by a factor. But their corrosion is impressive.
Question. So you talked about in a distribution destruction scenario where we have a Cat 6 or Cat 7 hurricane, and we have all of our substations and all of that sort of stuff completely knocked out.
Well, I think the substations will be all right, and the transmission lines will be all right. I think Belco might well be flooded.
Yeah.
But I think the distribution network, the distribution infrastructure will just disappear.
Do you know if Belco has any plans in place for a scenario like that? Would the probability of them becoming so much more real?
Yeah, that's a good question. I would say my greatest concern right now is a perceived lack of concern. I'm sure Belco is thinking about it, but it's human nature, right? We go we tend to basically understand our future by looking at what's happened in the past. And I think which is fine until recently. Now we're in completely new territory, and we really need to have our best and brightest minds starting try and predict what's going to happen in the future, and then take some steps to mitigate the impact that that's going to have on our lives, because that future is heading towards us anyway. So, Michael and I are, we're well into our 70s now. We might escape maybe the worst of this. I haven't got any kids. I don't have any grandchildren. Michael has grandchildren. Anybody here that has children and grandchildren should be very concerned about the world. When those kids that are being born today get to be our age, I have no idea what this, what the world's going to look like, but it's going to be it's not going to be a nice.
Of any Belco plan, they're already preparing themselves, having power lines on the ground. Okay, not every neighborhood, but the main streets. It will, prevent any bigger damage for the outlet.
Preventative measures they're taking is moving everything underground.
You are right.
Yeah.
And
That actually will be necessary. Sorry.
and then this is kind of a more Bermuda specific question, and kind of more industry specific, but
Speak up a little bit, just, but they,
yeah. So with Bermuda being a market where we have to be grid tied with even having solar and batteries on the house, you still have to be tied into the grid. In a destruction scenario like that, does that not almost eliminate the peace of mind that installing a system like that creates?
it's connected.
Yeah. Because you have to be tied, you have to be grid tied. So if the grid goes down and the limited number of households that have batteries on the island will obviously be able to run at a minimum capacity. But with half of the selling point of solar being peace of mind when the power goes out, not being able to use that power when Belco goes out is kind of a problem. That's very.
Oh, yeah, yeah, it's going to be a challenge. Now, there is good news in that regard. As, yeah, because Tesla's finally agreed that after next year, all of their cars will be coming off the production line with bidirectional power transfer. And, you know, I know Enphase, which what you guys sell, are already manufacturing a box. So, and this is actually good news if you have solar, because last I heard, by 2035, we're not going to be able to we're not going to be able to import gas-driven cars anymore. So everything's going to have to be electric. So those electric cars come with huge batteries, from 40 kWh to 60 kWh batteries, and you know, they're not going very far. So just only the top 20% of those batteries are ever being used for transportation. Now, if you have solar, you can use solar to charge your car. You can use your car to run the house at night. And to go back with, okay, we have to be tied to Belco. I have a very clever friend of mine built his own 40 kWh battery, and he has a switch.
Disconnect, yeah.
And so probably 60-70% of the time, that switch is down. He's just running off his solar and his batteries. And yeah, it's nice if you get a cloudy day and it rains for 2 weeks or something like that, you pop it back up and
Again,
get something.
most of Bermuda,
Yeah.
one isn't smart enough to build their own 40
Yeah.
kilowatt hour battery.
But if you got a small generator, you know, and an LPG tank,
Two
basically he could leave that switch off.
doesn't have the disposable income to have batteries of any kind on the house.
Well, that's going to be, sorry, Annie, but we're just moving into a really interesting discussion in the solar industry of going back to that divide of those with solar and those without solar. And I mean, if you can go on Google Earth, look at Bermuda, and you can see who's got solar and who doesn't. And it sort of breaks down into neighborhoods. It breaks and zoning, actually, because you know, residential 2 zoning, which is where people with disposable income live, are where you see the solar. Residential 1 zoning, where people don't have the disposable income, is where you don't see the solar. And it's actually breaks down on historical lines. So it's not really surprising if you've grown up in Bermuda and you're walking around with your eyes open, that it's kind of playing out that way. So the challenge now becomes for us in the industry, and I think this is what Jeff is telling me is true, is I think you're going to start to address this, which is, you know, long overdue. I'm very glad to hear that, in fact. We need to start figuring out how to get more solar in the residential 1 neighborhoods. And there's a lot of resources. There are a lot of resources in that neighborhood that are not being brought to bear because, generally speaking, you know, that's where the blue collar people with the requisite skills to be able to install solar, as the electricians and masons and carpenters and people who are very used to using tools and can easily learn how to to do that part of it. That's where those people live. So there are huge resources to be brought to bear there already. And we just need, it's hard to say what's going to drive that. I see it's starting to, there's starting to be more interest, certainly, in the residential one neighborhoods. We're getting more calls from people that live in those neighborhoods now, and more of our customers are now starting to come from those neighborhoods, which is a good thing. There are a couple of things the government could do that would really help. One of the really, there's a couple of really crazy things that are currently inhibiting that. And one is the charge that we pay, the facilities charge that we pay every month to be connected to Telco. That typically could be from $26 a month to $106 a month, depending on how much electricity you use. If you put solar in, it automatically goes to $46 a month. Doesn't matter how much solar and how much you were using before. So our richest or our biggest users, customers, are getting an automatic $600 a year savings by installing solar. As a matter of fact, Michael, if you wanted to save $600 a month, a year on your electricity bill, for example, all you would need to do is install one solar panel and connect it to your meter, to the grid. And your facilities charge would drop from 106, which is probably what it is most months, to 46. Now that's crazy, because if your facilities charge is $20 or $26 a month, and you put solar on your house, your facilities charge is going up, and you might actually be, it may be costing you more money to have solar than without. So that's a crazy thing that can be changed really easily, really quickly. The other thing is the planning. There's this planning rule. Typically, any existing building you can put solar on, and it's a what they call a PDP, a permitted development permit, and that's easy and inexpensive to do. The only time that's different is if the building is within a setback to a main road or a private road. The setbacks apply. So that's 25 feet from the boundary. If you want to put solar on any roof that's within 25 feet of a main road, now you got to go with a full DAB, development application. That is going to put an extra $2,000 on the cost of your solar just for the permitting. Now, again, who's this affecting? It's not affecting the people who live in residential 2 neighborhoods, because virtually all of them are set back from 25 feet at least from the road. But if you look on the planning map, basically at any residential 1 neighborhood, right? And you look at how many of the houses are closer than 25 or 20 feet from a main road, it's going to be like 35 or 40% of those houses. So anybody who lives in one of those houses is automatically penalized $2,000 just for living in that neighborhood. And that would be easily changed. And so there's a couple of things that we can do to help it. The other thing is everybody who rents, right? If you rent, you're not going to be interested in paying a lot of money out to put solar on a roof for your landlord. And your landlord is not going to be interested in putting a lot of solar on his roof for your benefit as a tenant. So the way to solve that is with community solar. And typically, you got to look for a huge field somewhere, and put a big ground mount, and you sell you can sell panels like that. But in Bermuda, that doesn't exist. But what does exist is a lot of roof area. And a classic example is I was talking to Reverend Pettit at St. Paul's in Patchett. We were just having a discussion because every time I drive by that roof on the church hall, I go like, yeah, it's such a shame that roof's not black. You know? And that's me right now. I see a white roof, I want to turn it black. It's like the Rolling Stones song, right? I think that's the best thing I can do in the last few years that I've left remaining in my life. That's probably the best contribution I can make before I step out. And so I was talking to Ant about it. His name's Anthony, but his nickname is Ant. And I was saying, you know, maybe there's some way we can do this. We can just put the panels on there, and you can get members of your congregation to invest. You know, you can buy 1, 2, 3, 4, 5 panels, and then all of the savings you get off of those panels, we can give you credit, somehow give you credit on your Belco bill. And, you know, it'd be a great thing. And he's thought about it for a little while. And he goes, yeah, but we wouldn't do that. So what we would do is we would go to the congregation and we would say, how many in the congregation want to donate some solar panels to people that are less fortunate than you? They really need some help with their Belco bills. And, you know, if you start thinking about that, there are a lot of creative ways that you can do to make the distribution of solar in Bermuda a lot fairer. And now all we need is a feed-in tariff for community solar. Right now, the feed-in tariff, you get 19 cents a kilowatt hour. So if you're fortunate enough to own your own roof, you know, and have some, well, you can go to the bank now. All the banks have green loans. And to put solar on your roof, everything that you self-consume, the value of that electricity is like 52 cents a kilowatt hour, because Belco buys the power from you for 19, sells it back to you 2 hours later for 52, right? So everything that you can self-consume is worth 52 cents a kilowatt hour. Everything that you sell back to Belco is worth 19 cents a kilowatt hour. So the actual value of the electricity that you produce is somewhere in between, somewhere around 32 to 38 cents a kilowatt hour, depending on, you know, if you want to cheat, you undersize your system. You know, if you just love solar and you put a lot of extra solar on it, then the value goes down. But so what we really need in order to get this idea of community solar going is for the RA to produce a special feed-in tariff for community solar. And that would be somewhere around 32 to 38 cents a kilowatt hour, I would think. Right now we can do it, but you have to sell, you know, like if we put all those panels on the church hall, for example, it's a small user. It's got well, that's a special case because they have a government-run nursery school upstairs. But most church halls, you have a small office with 3 people in it, 2 or 3 people in it, and they're not even there, you know, for a full working day. They're just there part-time. Their bills are small, so huge capacity for generation, very small demand, and there are a lot of all of the warehouses like that. Oops, sorry, I like that. There are a lot of roofs like that in Bermuda. As a matter of fact, we were at the Green, the Living Green Expo, for example. That is virtually no. That's a roof that has virtually no demand. It's this huge roof that produces a lot of electricity. And you know, if there was a reasonable fit for community solar, it would immediately come into play. The other thing is, I was looking at the parking lot at City Hall. And so I was talking to Charles Gosling about it, you know, and he expressed some passing interest over a glass of wine. So I went home and I pulled out my solar design software and, you know, you got to keep it under 500 watts so that you don't need a license, KW, I mean, kilowatts. So I did that. As it turns out, it works out perfectly. And worked to figure out what the cost would be in the whole thing. And it makes money, but it makes like about 4%. And, you know, over 25 years. And basically Charles looked at that and said, that doesn't work economically. I said, well, okay, fair enough. That makes sense. At 19 cents a kilowatt hour, it doesn't work. Now, 3 or 4 years from now, when everybody's got an electric car with bidirectional power transfer, now imagine, you don't even need solar. All you need to do is drive your car into town, park it, plug it in, spend a couple of hours shopping, go to the movies, have coffee or lunch with your friends, go back, detach, say you're paying 35 cents a kilowatt hour for that power. Take your car home, plug it in. Now you've got a huge discount on your power. So when we look at the future for solar and all of the potential, particularly, you know, with the new technologies, with bidirectional power transfer, with a couple of small tweaks within, it's not change any laws, just some small tweaks within policy. There's a lot we can do, but I'm going to stop there. But Annie had a question.
Actually, you may have, in that whole discussion, answered. I was talking about looking around the island, seeing where you have panels and you don't. And being an East End person, there's a definite shortage of panel centers in St George's. So I was wondering if planning permits panels on listed buildings.
Yes.
Because it's a lot of residential one.
Yeah. The question is yes, but in St. George's, you have to get the historical preservation.
But they are allowing.
To say yes, and basically, if they can't see it from the main road, they'll say yes.
Okay.
So, yep, when you look on Google Earth, you'll start to see a few panels in that. So
we installed on Schedule 1 protected land.
Okay.
It's just, it depends on the owner of the property and what parts of the building are original. If it's original roof, you obviously don't install on the roof. You have to look at like a ground mount system. But there are certain ways that we've been able to work around installing on Schedule 1 properties.
Okay, but not on the roof. Okay.
There's one case where like half the building was a new build and the other half is original. And we were allowed to install on the new roof, but you weren't allowed to install on the old roof.
So is that because of the structural integrity, or is that because of the historic value?
historical value.
So, okay, so that actually eliminates an awful lot of St George's then. Yeah.
You have a question?
Just a quick question. What's the likelihood of the relationship with Belco and the feed-in thing and the standalone systems such that they could have a community perhaps generating and sharing power? What's the likelihood of?
Well, there are a couple of different features. There's like, you can go through door 1, you've got this feature, you can go through door 2, you can get another feature. Essentially, the best thing that could happen is that Belco maintains a very healthy grid. And that wherever anybody who has an electric car with bidirectional power, now there's probably be 15,000 of those within the next 10, 15 years. Everybody that has, now most of those cars are parked 90% of the time. So wherever that car is parked, if it's plugged into a bidirectional power transfer, which is part of the grid, then Belco now has like a 900 megawatt hour distributed battery attached to their infrastructure for free. It hasn't cost them a penny, because you can look at it two ways. If you have a car with bidirectional power transfer, you have a car and you have basically a home storage battery or a distributed storage battery, right? if you bought the battery by itself, it would cost the same as the car with the battery in it. So you're getting one for free. You know, you're either getting a battery for free or you're getting the car for free.
Are those plans being
And-
developed?
Not according, not according to my mate. I have a good friend that works there at Belco, and I like to talk to him about this and talk about the vision that, different scenarios that we have. Belco is a traditionally run business. So they run their business, and they're a lot more concerned with making sure that we have good quality electricity today, tomorrow, next week, next month, next year. And that's their main focus. And quite frankly, that takes up 90% of their energy.
We should talk. Let's
So,
talk.
yeah. So that's, that's a discussion that hopefully presentations like today will start. And I think there are people I know there are people within Belco that are at least thinking about it.
Along the lines of the future of solar, where a lot of the mounting systems that we have, especially our roof mounting systems, they're rated for 155 to 180 mile an hour winds. So if we start seeing hurricanes on a regular basis that are above that, that then starts to make us worry about warranties and the viability of still being able to install on Bermuda roofs if we're going to be seeing more hurricanes that reach that threshold of being over our warranted wind rating.
Yeah. So if we go back a couple of slides.
Brief, I think.
I will, yeah. I know everybody has to go. We go back. Now, this is quite an old system. I'm looking at that. It looks like they might be polys. I bet you that racking system there was probably engineered for 150 or something like that. I'm sure the building codes at the time certainly didn't require, but if you're like us at Sunnyside Solar, everything is rated at a minimum of 180 miles an hour in our designs, because I think within the next 25 years, the lifetime of that system, that we're likely to see that. And there's some redundancy built into that, obviously.
So just before we finish, is it possible for you to share with us some other ideas of things we can do to prepare? You said that the best thing we could do is prepare. What sorts of things can we do to prepare? Or if you want to think about that and let us have it, we can post it on the.
So what I was thinking about was a pump and a little rubber dinghy, and then when I pump half the water out of my water tank, and then getting in the dinghy and riding it out as a bunker.
For a hurricane.
Listen. I mean, this is scary. Just another quick anecdote. A friend of mine was talking to somebody who's moved his business from Puerto Rico to Bermuda after their big Cat 5 hurricane went through there. And he was saying, "Oh, yeah, it was terrible. I had no internet, I had no electricity. My kids couldn't go to school. Hospitals were down. I mean, and it was a mess, and there were security issues." He just said, "Look, I couldn't sustain my business there anymore." So he packed up, and moved to Bermuda. And my friend went, "Yeah, well, up here in Bermuda, we have much better building codes." He said, "No, you don't understand." He said, "Down in Puerto Rico, I lived in a house just like the one I live in here." He said, "In the middle of that storm, I had to take my family to the lee side of the house because fist-sized rocks were punching through the cinder block. So if you have a 200-mile-an-hour gust of wind and it picks up a rock like that, that rock is traveling fast enough where it's going to come through your walls." And that's that's what we're looking, and when you think about, how you want to prepare, I mean, quite frankly, I think would be really smart to, see if there's some place in the middle of your house where you could go and shelter.
A water tank.
Sure.
In your little rubber dinghy, in your water tank.
Yeah, in the water tank, yeah.
I remember seeing a picture from Fabian, and that was what? You remember Max Winspeed and Fabian?
Yeah, that was a Cat 3.
Yeah. And there was a picture of a palm tree picked up and like shoved through someone's wall. And that's in relatively low winds compared to what we're talking about.
Exactly.
Any final questions?
I have one. What's the lifespan of the solar panel?
25 years. Well, actually, 40 years still. There's solar panels that were installed 40 years ago that are still working.
And so what the warranty is it's a production warranty. And basically that means it'll be producing at over 80% efficiency for 25 years.
Okay.
After the 25-year mark, they can't guarantee that it won't drop below 80.
All right, good to know.
So thank you,
No, you're
Nick,
very
for the
welcome.
bad news. But the best way I can think of it is, forewarned is forearmed. So hopefully we'll come up with some ideas better ideas for preparations, things we can do for preparations. In the meantime, we'll find a space in our homes to aim for, should the weather. Thank you to Nick, and thank you also to Amy Harvey and Jennifer Flood, Amy from the college, Jennifer from Best, who worked diligently and have done since I think 2018 to put on these lunch and learn presentations. Please stay tuned for the 7th in the series, which begins in September, and notifications will go out. Please join us. Please encourage your friends to come. In the meantime, let's see what we can do in terms of how we can play a part in whatever to make Bermuda a sustainable place to live. Thank you very much. Nick, some questions, other questions if you like. Thank you, Nick. Sure. So we'll be back in